first example, I was testing a PCB. It's requiring me to calibrate the current, so the current limit of the device, and setting the output voltage. And then testing it with the current monitoring disabled and testing it with the temperature monitoring disabled to see if it all still works. What I was doing on the computer, that was me updating some of the electrical schematic designs to suit the actual part that's come in, and how the guys have discovered that the designations of the actual part where they have to connect to doesn't quite line up with the initial information we've got for the part. So real world, you get told this is what the part is, these are the connections to it, but what you might actually end up in hand is sometimes always different.
I work with the parts list, which tells me where the components get loaded in the right direction. So first what I did, I assemble little resistors and diodes in the right destination on the circuit board. And then I flip over the lid, and then I solder every component underneath. And then using hand tools, just cut the wires short so the PCB is nice and flat underneath.
Okay, the first thing I did there is basically I made the polymer. Then prior to starting the job, I gathered all my materials, cables, insulations, and then I load up the polymer to the mandrel, and then load up to the machine. Prior to that, I load up some of my copper wire already there. It's the copper strip and the copper wire. This is I'm using a 3mm copper wire and a 10 by 4 copper wire, copper strip. Prior to the starting of the winding, I have to reset the counter of the machine to 0 to make sure that I'm gonna get the exact turns. So after loading up the mandrel to the machine, I connect up the starting lead, which is I use a required 2.5 square millimeter black cable. So after securing the purse, the starting lead to the polymer, so I start winding through the one layer. After finishing first layer, I have to put insulation in between. So I kept going with the process, putting insulations in between the layer until I reach the full turns, which is 219 turns. Then after that, I terminate the finish lead, which is orange color. And then after securing the finish lead to the former, I have to wrap a 3 turns of high ply material to protect the primary winding. Then after that, I have to put a shield between the, as required, between the primary and the secondary winding. So just simply connect a thin copper into the around the primary winding, and then again another 3 wraps of a high ply, which is prior to the secondary winding. I have to wrap with a corrugated material as required.
So the assembly of the gear tray, you have all your components, so you collect everything for that gear tray. It's going to be assembled, and then you basically got to work out a layout. So we've got a drawing that we go by, and that our loom is the first thing that we start because it's from the card, and we do the loom first, and from there on we just run all our cable all through the ducting and get the gear tray done. We get our cabinet in, we put the gear tray in, and then we put the outer door on, so that gets assembled. And then we start running all our cables to the door, and then we put our floor in. So we've got 2 transformers and a choke that goes in, and we start wiring that up. It would take us 3 days, roughly 2.5 days.
The AutoCAD drawing is for a rectifier, and one of the requirements for it is that it's got what's known as provision for fire interference. And so I was adding an extra connection in with a variable resistor, so you can basically tune what the equipment does to see how it interferes with another piece of equipment that is connected to it. So it protects one pipeline. If there's another protection system on another pipeline, they'll interfere with each other, and you use this to tune the response between the two. The total thing took about 4 or 5 hours to modify to the point where we're at now. This one took about 20 minutes talking to the customer downstairs in the test bay. We banged out what actually we wanted done. We worked out how we were going to do it. A quick line drawing on a piece of paper, and I'm just converting it up, so it'll take 10 minutes. The second thing I was doing was looking for a variable resistor, which is a kind of resistor where you can change resistance, usually by a knob or a slider, and that's actually used in this one as part of the tuning process.
So I was wiring up the control wires for the contactors, the main contactors that control the incoming AC to the transformers. So that's all mains voltage 415 volts AC, which you would get out of the power lines outside your house basically. And then that turns on and off. That then goes into the transformers. The transformers then change the voltage from 415 down to 15 volts. And that increases the current quite substantially from, I think it's about close to 80 amps from the wall all the way up to 3000 amps. The unit itself is generating hydrogen through electrolysis. Certainly the biggest thing that I've worked on. So the wires are meant to be labelled. They've also got numbers on each wire. So the idea is that wire corresponds back to the drawing. If somebody hasn't labelled the wire properly, at least you can go find the wire number